Hello friends, this video is brought to you by www.moeteaching.com.
We now start with understanding and then deriving section formula. Say we have 2 points A and B. We want to position a tower at point P in such a way that distance of the tower from B is twice as much as distance from A. That means P lies on AB and it will divide AB in the ratio 1:2. That is, we have AP is to PB is 1:2. Now, in order to know the position of the tower, we must know the position of point P. Say we take coordinates of point P as x and y, and we are required to find x and y. For that, what we'll do is draw perpendiculars from P and B on the x-axis. After drawing the perpendiculars PD and BE on x-axis, also draw a perpendicular from point P on BE. Now consider two triangles that you can see on the screen, that is triangle PAD and triangle BPC. Clearly, these two triangles are similar by AA criteria. Let us quickly see how. We know we have two 90-degree angles. Also, PC is parallel to AE. Corresponding angles will be equal. That means angle P is equal to angle A. So the triangles are similar by AA criteria. That means sides should be in ratio. Let us take them two at a time. We have AP by PB equal to PD by BC. AP by PB is known to us. PD should be Y, that we have to find out, and BC will be 8 minus Y. Similarly, AP by PB equal to AD by PC will give us 1/2 equal to AD should be X and PC will be 9 minus X. By solving 1 and 2, we can find value of X and Y and hence the coordinates of the point P. We have now understood that section formula is basically a formula to derive the coordinates of point P, which divides the line segment AB joining the points A and B internally in the ratio m1:m2. In this case, it is 1:2. Let us proceed with the derivation of the section formula. We start with coordinate axis Say A and B are any two points with coordinates x1, y1 and x2, y2. Assume that point P, whose coordinates are x and y, divides AB internally in the ratio m1:m2. That is, we are saying PA by PB is equal to m1 by m2. Our next step will be to draw perpendiculars from point A, P and B on x-axis. Name them R, S and T respectively. Also draw a perpendicular from A on PS and P on BD. Now triangle PAQ will be similar to triangle BPC by AA criteria, which we have discussed in the previous example. Therefore, we will have the ratios equal PA by BP equal to AQ by PC equal to PQ by BC. Let us find AQ, PC, PQ and BC. AQ will be OS minus OR, but OS has to be X as coordinates of point P is X, Y. So X on the x-axis and OR will be x1, so it comes out to be x minus x1. Similarly, PC will be x2 minus x, PQ will be y minus y1 and BC will be y2 minus y. Now, from the ratio equation, taking 2 at a time, we know PA by BP is m1 by m2. Using this, we can find the value of x and y. We start with the first two. PA by BP is m1 by m2. AQ is x minus x1. PC is x2 minus x. Let us solve this further. This will give us m1 into x2 minus x equal to m2 into x minus x1. Open the brackets. X terms on one side will give us m1 x2 plus m2 x1 equal to m2x plus m1x. Solving further, we will get x equal to m1 x2 plus m2 x1 whole by m1 plus m2. We start with coordinate axis. Say A and B are any 2 points with coordinates x1, y1 and x2, y2. Assume that point P, whose coordinates are x and y, divides AB internally in the ratio M1 is to M2. That is, we are saying PA by PB is equal to M1 by M2. Our next step will be to draw perpendiculars from point A, P and B on x-axis. Name them R, S and T respectively. Also draw a perpendicular from A on PS and P on BD. Now triangle PAQ will be similar to triangle BPC by AA criteria, which we have discussed in the previous example. Therefore, we will have the ratios equal PA by BP equal to AQ by PC equal to PQ by BC. Let us find AQ, PC, PQ and BC. AQ will be OS minus OR, but OS has to be X as coordinates of point P is X, Y. So X on the x-axis and OR will be x1, so it comes out to be x minus x1. Similarly, PC will be x2 minus x, PQ will be y minus y1 and BC will be y2 minus y. Now, from the ratio equation, taking 2 at a time, we know PA by BP is M1 by M2. Using this, we can find the value of x and y. We start with the first two. PA by BP is M1 by M2. AQ is x minus x1. PC is x2 minus x. Let us solve this further. This will give us M1 into x2 minus x equal to M2 into x minus x1. Open the brackets. X terms on one side will give us m1x2 plus m2x1 equal to m2x plus m1x. Solving further, we will get x equal to m1x2 plus m2x1 whole by m1 plus m2. Similarly, using the second part, we get PA by BP equal to PQ by BC, which will give us M1 by M2 equal to y minus y1 by y2 minus y, which on solving will give us y equal to m1 y2 plus m2 y1 whole by m1 plus m2. Hence we have coordinates of point P, x and y. P divides line segment joining the points A, x1, y1 and B, x2, y2 internally in the ratio m1 is to m2, and coordinates of point P are given by the following expressions, which is known as the section formula. Special case of section formula is if P divides AB in the ratio k is to 1, then the section formula becomes k times x2 plus x1 whole by k plus 1, and the y coordinate will be k times y2 plus y1 whole by k plus 1. Another special case is if P is a midpoint of AB, this will imply that the ratio m1 is to m2 is 1 is to 1, and then the formula becomes 1 into x1 plus 1 into x2 whole by 1 plus 1, 1 into y1 plus 1 into y2 whole by 1 plus 1, that is x1 plus x2 by 2 plus and y1 plus y2 by 2, which is also known as midpoint formula. Please remember these formulas. Let us read the question. Find the coordinates of the point which divides the line segment joining the point 4, minus 3 and 8, 5 in the ratio 3 is to 1 internally. So we have coordinates of point A and B and the ratio in which the coordinates of the point required divides AB is m1 is to m2 is also given to us. We have to find the point P xy, which will be given by section formula. Let us recollect the section formula. Now let us find x coordinate of such a point by substituting the values. We have m1 as 3, x2 is 8, m2 is 1 and x1 is 4 whole divided by m1 plus m2, or basically 3 plus 1. This will give us 24 plus 4 whole by 4, 28 by 4, that is 7. So x coordinate of point P is 7. Similarly, calculate y coordinate. Therefore, 7, 3 is the required point. Let us read the question. In what ratio does the point -4, 6 divides the line segment joining -6, 10 and 3, -8? Let us try to understand the question. Basically, we are given point A, point B and coordinates of the point P which divides AB in some ratio, and we want to find that ratio. Actually, according to section formula, we should take M1, M2 and calculate the ratio, but there is an alternative method which is easier. We start with the ratio M1 is to M2, which can also be written as M1 by M2 is to 1, which can be written as K is to 1. So now we will find the ratio K is to 1, and we will interpret that point P divides AB internally in the ratio K is to 1. So let us use the section formula and find x coordinate of point P using the ratio K is to 1, which will be, here x coordinate is given to us, which is -4. So we have -4 equal to, our M1 is K and M2 is 1. So we have K into x2 is x coordinate of point B, that is 3. Now M2 is 1 and x1 is x coordinate of point A, whole by K plus 1. Let us cross multiply and solve this further. Solve this further, we get minus 4k minus 4 equal to 3k minus 6, or 7k equal to 2 by bringing the like terms together. This gives us k equal to 2 by 7, which implies that the ratio in which point P divides AB is 2 by 7 is to 1, or we can say 2 is to 7. We can check with the y coordinate of point P and we shall get the same answer. Let us look at alternative method. Let us assume that P divides AB in the ratio M1 is to M2 internally. Then we know the section formula. Let us substitute the values. X and y coordinate are given to us, and it is equal to 3 times M1 minus 6 times M2 whole by M1 plus M2. Just substitute the values. Minus 8 times M1 plus 10 times M2 whole by M1 plus M2, which gives us minus 4 equal to 3M1 minus 6M2 whole by M1 plus M2, and 6 equal to minus 8 times M1 plus 10 times M2 whole by M1 plus M2. Now we can cross multiply and find M1 and M2. Let us solve the first one. We get minus 4 times M1 minus 4 times M2 on cross multiplying, and 3 with this comes equal to 3 times M1 minus 6 times M2, which is equal to 7 times M1 equal to 2 times M2 Can we find m1 by m2? We will get m1 by m2 equal to 2 by 7, or this means m1 is to m2 is 2 is to 7. We should also verify that this ratio satisfies the y coordinate. So let us do so. To check whether m1 by m2 equal to 2 by 7 satisfies the y coordinate, let us take the left hand side of the y coordinate equation. We get -8. If we take out m2 common, we get m1 by m2 plus 10. Again, taking out m2 common from the denominator will give us m1 by m2 plus 1. So now we can substitute m1 by m2. We get -8 into 2 by 7 plus 10 whole by 2 by 7 plus 1. We can solve this further and we will find that we get equal to right hand side, that is 6, implying that m1 by m2 equal to 2 by 7 satisfies the y coordinate also, and hence the point P, which is -4, 6, divides the line joining point A and B in the ratio 2 is to 7.